Okay, so let us start today's lesson. We want to talk about the polar form of a complex number. So this is the first time in mathematics probably we are making things a little bit harder. Usually we need to simplify things as much as possible, but probably this is the first time that I give you a simple, innocent, complex number, and then we want to involve it with trigonometry and make it more complicated. The reason that we make it more complicated is because later we will see that how beneficial is this work if I want to raise a complex number to very high powers. Okay? Because in principle, let me just a little bit motivate you. So you know that if I give you, you remember if I give you 1 plus I to power 100, even though the power is so big here, it was simple because of some coincidence. Yes? Do you remember why was it simple? Because when I raise it to power 2, what happens? It becomes the first one to the 2, 2 times the first one times the second one to the 2. And then this I squared and 1 coincidentally cancel here, and I get 2i. And I can say that 1 plus I to power 100 is actually 2i to the power of 50. Yes? And then this becomes 2 to the power of 50. And instead of I to the power of 50, I can write I to the power of 2 to the power of 21 to the 25. And this becomes negative 2 to the power of 50. Okay? This was a coincidence. But let me just change this 1, I don't know, to 2 plus I to the power of 100. Yes? Then this doesn't work, yes? Because if I raise it to power 2, you see, it gives me 4 plus 4i plus I squared, which is minus 1, and then it becomes 3 plus 4i. So again, I have a binomial. So you see here, the reason that calculating this was simple is because by coincidence, when I raise it to simple power 2, it becomes a monomial. You see, I have 2 terms, it's a binomial, but coincidentally, when I raise it to power 2, it becomes a monomial, and raising monomial to any power is simple, yes? It's easy. But here, if I raise it to power 2, it's a binomial. By raising it to power 2, it's still a binomial. So I have to raise it gradually, yes? Because it's hard to raise it to power 100. By the way, how many terms are involved here? 2 to the power of 100 terms, which is actually astronomical number, yes? Assume that this is 10. You have 10 to the power of 10 terms, which is 1024. So if you just want to raise it to power 10, you have to deal with 1024 terms, yes? So you see, hopefully you agree with me, even though this principle technically and in principle is simple, I have to multiply it 100 times, but practically it's probably impossible for us to do it. So this is the reason, this is the price that we will pay. We make this number, write this number in a more complicated form, which is called the polar form. And then you will see that if I can write it in polar form, answering this to power 100 would also be very simple. Not very simple, but practically possible. Yes? Is that understandable? So now forget about these things. Let us learn what do we mean by the polar form of a complex number. To do this, I have to define the argument for you first. Okay, we talked about the absolute value of a complex number, but let me just talk about the argument of a complex number. So I would say that let z not equal to 0 be a complex number. The angle theta greater than or equal to 0 less than 2 pi, that the vector corresponding to z in the complex plane makes with the positive real axis is called the argument of Z and is denoted by, yes, by this symbol, ARG of Z. Yes? So what does it mean? Do you remember I told you that if you have a complex number, if I have, this is the real axis and this is the imaginary axis, assume that I have Z, which is my complex number. Then for every point in the complex plane, I can associate a vector with it. So this is the vector corresponding to that point. And this vector with the positive part of the real axis, it makes an angle. Yes? This angle is called the argument of Z. Yes, is that understandable? So that's just the definition. Of course, it is clear why should Z equals to 0 should be excluded. Why do you think it should be the case? Yes? Yeah, that angle is not defined. If Z is equal to 0, you have one single point, and it is meaningless to talk about the angle between a point and a line. Yes? So for having argument makes sense, Z shouldn't be equal to 0. So then Z is not equal to 0, it is somewhere on the plane. You connect the origin to that plane, to that point, and measure the angle between the vector with the positive part of the real axis. That's the convention, it's in the definition. That's called the argument of the complex numbers. Is that clear? And then let us talk about this. This is a little bit of convention going on. In more advanced texts, they consider theta to be between a minus pi and pi. Okay, but usually I think this is a little bit problematic at this level. Let us stick to this convention, and this is more natural, yes? And then you see that I have included 0, I have excluded 2 pi, because essentially they are the same thing, yes? So if I include both of them, then it would be ambiguous. If I have a line, if I have a vector here, so if I ask you what is the argument of this number, which one you prefer to say according to convention?
0.
0. In principle, you should be able to say 2 pi. So I am excluding 2 pi, I am including 0 by convention. So is that understandable? So this is a very simple task to do. So let us give you some examples. So let me write this example here. So determine the argument Okay, so for example, let me just start with a very simple one. If I give you Z equals to 5, some of them you really don't need to calculate anything. So what's the argument of Z equal to 5? Do you agree with me? Because, so 0, yes? So here you put 1, 2, 3, 4, 5, and then you draw this arrow. So this arrow represents this. And what's the angle now? You see the vectors are lying on top of each other, so it is 0. So the argument of Z is 0. Agree? So what do you think about this scenario? Z is equal to minus 3i. No. You need to also respect the convention. So it is important. So in all this Origo book, we stick to this convention. So it means that if I ask you about the argument, you need to respect the convention. But first of all, you cannot say pi over 2. If you want to say something, you should say minus pi over 2. Yes? Because minus 3i, where minus 3i is on the complex plane, 1, 2, 3, here is negative 3. So this angle, this is your Z. Do you agree? Okay, so if you want to say this, I'm not saying it is impossible, but if you want to name this angle, you shouldn't say pi over 2, because pi over 2 will be up there. So this is minus pi over 2. But if I want to use this convention, minus pi over 2 is the answer. Yes? But if I want to stick to this convention, what should I answer? Yes? 3 pi over 2. So is that understandable? So I would say that I will consider it 3 pi over 2 because this is my argument now. So this is 3 pi over 2. So the argument, by the way, at this level, you can choose yourself. If you want, you can write it in radians, or if you want, you can write it in degrees. Both of them are correct. Yes? But this is in radian, this is in degrees. So for example, what do you think about this situation? Z is equal to minus 10. Just imagine it in your head. What is this one? Yes?
Pi.
It's pi. Yes? Is that understandable? So if you don't understand, please let me know. So the argument here is pi or 180 degrees. Agree? Okay, but let us make it a little bit more complicated. So what happens if I have this, for example? So z equals to 1 plus I. I want to find the argument of this. Okay, so in principle, what I need to do, I really recommend you to do that, even if you can visualize in your head. So the real part is 1. The imaginary part is also 1. So this would be the point z, and this would be the vector. So in this picture, you immediately realize that this angle is your argument. It's very easy. What's that angle? Everyone. It's 45 degrees or pi over 4, yes? But technically, how you should solve it, so how should I solve it? I would say that I will call it theta, and I use tangent of theta. Tangent of this angle is the length of the opposite side, which is equal to 1 in this case, divided by the length of the adjacent side, which is 1, so it gives you 1. The reason that I want you to learn this, because it might be an angle that I cannot calculate it on top of my head, so I need to write it and calculate it using the calculator. So in principle, you say theta is tangent inverse of 1, and if you don't know it by heart, you can use your calculator or the table of values, you get pi over 4. So the argument of this is pi over 4. Yes? But now let me give you another scenario. What happens if I switch this and write minus 1 minus I? So what is the argument of this one now? I really recommend you, for finding argument, don't be lazy. Try to draw some rough diagram for yourself. So the real part is minus 1. The imaginary part is minus 1. So this is, let me just 1 unit, yes? In principle, if I want to point this, it is not 1, it is minus I on this axis. But anyway, the length is 1 unit. So then you need to find this, and then you realize that by definition, this is your argument. This is something that you need to answer. Yes? Okay, so how should I answer this one? For example, I recommend you to calculate this alpha using formula. So how? I would say tangent of alpha is equal to the length of the opposite side. The length is 1 unit divided by the length of the adjacent side, which is also 1. So you get 1 immediately by the same trick. You learn that alpha is pi over 4, but you're not allowed to say the argument is pi over 4. The argument is this bigger blue angle. And what that angle is? Yes?
Pi over 4.
So how did you find that?
I added pi.
Yeah, I added 5. Yes, exactly. Because from here to here is pi. We know about this. From here to here is pi. And then I want to add this alpha to it. So the argument, it's important. If you say the argument pi over 4 is wrong. So you have to write argument is what? Pi plus pi over 4. So these kinds of adjustments are simple. You can do it by drawing a picture on yourself. Yes? Is that clear? Yes or no?
Yes.
Yes. Okay. So the argument is actually is not that hard. But let me make it a little bit non-trivial. So for example, let me write this one, number 6, give you this example. z is equal to, for example, square root of 3 minus I. We want to find the argument of this. Okay, so how should I do that? First of all, I draw a rough diagram for myself here. You don't need to be precise at all, yes? So the real part is a square root of 3, so assume that this is a square root of 3. The imaginary part is minus 1, so I've considered this to be minus 1. Then I will find my vector. This is my vector. Okay, so what is the argument? The argument is from here to here. So this is what is missing. Okay? And I want to find that angle. But always, always try to find this acute angle. Call it alpha. This will help you to find the whole angle that you are interested in. And always you use tangent. Yes? Always. So what you do, okay, tell me. I write tangent of alpha. This is equal to the length of the opposite side, which is how much? What is the length?
Minus.
No, the length.
1.
Be careful. In this method that I am teaching you, ignore the signs. Only the length. Okay? Not negative signs. Tangent of alpha is the length of the opposite side, which is 1, divided by the length of the adjacent side, which is square root of 3. I am looking for alpha. This is, of course, a famous angle in trigonometry. If you have it in your memory, you just write it down, or not, you just use the calculator or the table of values. And what you get is the answer is, you remember? It's pi over 6. So the tangent of 30 degrees is 1 over square root of 3. So this gives you alpha. But what is my theta? What is my theta?
5 pi over 6.
2 pi minus pi over 6. Yes. 2 pi minus pi over 6. So you calculate this, it becomes 11 pi over 6. So that would be the angle. If you are using the other convention, in this case, what we say minus pi over 6. It might be sometimes simpler, but let us stick to one single convention so that you are not confused. So is that understandable? Yes or no? Okay, so let me make it like this. What happens if the numbers are not quite good? And if you want the exact value. So number 7, so let me write z equals to, I don't know, let us just write something random, but 3 plus 4i. And let me play with negative signs a little bit. So let me this time give you, no, this is good, let me make it negative. Minus 3 plus 4i. So what can I do here? Again, I will follow the same strategy. I want to find the argument of this complex number, so I will draw it. So minus 3 is minus 1, minus 2, minus 3 is here, plus 4, 1, 2, 3, and 4. So this would be minus 3, and this would be 4. Of course, I am telling you, writing 4 is wrong. I have to write 4i, but from the length point of view, that's 4. And this would be my vector z. So which angle I am interested? Always, based on definition, I will have to start from the positive part of the real axis. So which one do you prefer to call alpha? You have two options. In each of them, you have two options to call it alpha. If you want, you can call this one alpha, or if you want, you can call this one alpha. If you call this one alpha, if you want to find the blue one, you write pi minus alpha. If you take this one to be alpha, then you need to write 90 plus alpha. It doesn't matter which one you call, so you have this freedom yourself. So I don't know which one. Let us consider this to be alpha. And this is theta, of course. This is missing theta. And I always told you that use tangent always for alpha. So tangent alpha is the length of the opposite side. What is that?
4.
4. And the length of the adjacent side is 3. But this is not one of those angles that are famous. What we can do, we can write alpha is tangent inverse of 4 over 3. If you want the exact value, you have to keep it exact. Later in the university, you learn how to work with these exact values. So it is actually valuable. If you want an approximate value, of course, you can put this in your calculator and find the approximate value. But I would prefer to keep it exact value. So this is good to know. But what is my theta? Now, can you tell me? Let me tell you something. As whenever you put a positive number here, alpha always becomes an acute angle. So don't get confused about this point. So even if you don't know the value of this, if you stick to what I said to you, positive, positive, even if you put this in the calculator, make sure that this is always an acute angle. So don't worry about that. This is always an acute angle, even if you don't know the exact value. If tangent inverse of a positive number is always an acute angle. So what is theta? If I want to have the exact value in this picture, I would write pi minus that angle. You see, this is an exact value. At the and in high school level, might be it is a little bit hard for you to work with this type of numbers, okay? Exactly, but you will learn how to do it in the future. So if I ask you what is the argument is just this one. If you want to approximate this argument, of course, you put it in your calculator and approximate it to some degrees. Yes? Is that understandable? Yes or no?
Yes.
Okay. Now, let us start talking about the polar form. For the polar form, I want to make things a little bit complicated, as I told you. So what can we do? We can do it in this way. Let me just try to motivate you at least for one case. In principle, you should have this argument for all the cases. So let us consider that this is the vector corresponding to my complex number z. So if you don't mind, let me consider that x plus yi is the standard form of my complex number. That's the standard form, yes? Now, if it means that for this particular actually shape that this is in the first quadrant, this length is exactly equal to x. And this length is exactly equal to y. And this angle, theta, is exactly equal to the argument of z. Yes? That is our setup. Yes? But now, can you see what is the connection? Okay, can you tell me what is this length, by the way? We had it in the previous session. What is this length called? Yes? The absolute value, or the modulus, yes? So the distance from any complex point to the origin, which we denoted by r here. So r, what is r here? R is the length or the magnitude or modulus or absolute value of this complex number, okay? And now let us see. If I ask you to write the formula for cosine theta in this right angle triangle, what do you write? Cosine of theta is the adjacent side divided by the length of the hypotenuse, yes, which is r. But then let me multiply everything by r, so it becomes r cosine theta. And then I would write the same thing for sine theta. It becomes what? Y over r. Do you agree? The opposite side divided by the length of hypotenuse. And then I multiply everything by r, so it becomes r sine theta. Now, let us go back to my original number. My number was x plus yi. But what can I do? Instead of x, I can write this. Instead of y, I can write this. So, something like this. And then you see that there is an r in common between these two. I can factor it out. So what can I do? I can factor it out so it becomes r cosine theta. It becomes sine theta times I, but it is a little bit ambiguous if I write it like that. So we prefer to write I on the left-hand side. Okay? This is called the polar form of your complex number. Okay? So if someone asks you what is this, I would say that is exactly the same number represented in a different coordinate system with the magnitude and the argument. Yes, so you see that which one is simpler, this one or that one. It's clear that this one is much simpler. So this is the first time apparently we are making things more complicated. There is a good reason for that will become apparent later. Okay, but this is this is called the polar form of your complex number. So this is a very important exercise. I give you a complex number and I ask you to write its polar form. Yes? So you need to learn how to do this. And this is easy. You need to remember this formula. Of course, this formula is in the formula sheet. But you need to know what are these numbers. What is R? R is the modulus of your complex number, and theta is the argument. So you have to first calculate R, you have to calculate theta, and then plug them in this formula and stop there. Because if you want to simplify it, you will go back to your number. There is no point of simplification. You are thinking things a little bit hard. Is that understandable? Yes or no?
Yes.
Okay. So now let us do some exercise. For example, can you tell me, oh, this is a little bit, yes, this one easy. So if I want to write the polar form of this one, can you tell me what should I do here? I want to do the polar form. We have already done everything more or less. So we found theta, it's 11 pi over 6. Okay? I need theta, but I also need R. Do you remember the formula for R? R is absolute value of z, which is square root of the x value to power 2, the y value to power 2. So if I calculate, this is 3, this is 1, 4, square root of 4 is 2. So R is 2, yes? So what I need to do, I would write z is equal to, instead of R in that formula, I put 2. Instead of theta, I will put 11 pi over 6 plus I sine 11 pi over 6. Yes? If someone asks you, what is this? This is exactly the same number. But which one you prefer at the moment? Well, definitely you prefer this one. Yes, not this one. But you will see why we are making life a little bit harder for ourselves. So that's it. You have to stop here. If you put these numbers in your calculator and you calculate, you will get the same thing back. So that is not the point, to calculate something. The point is to write that in this new form. This means to write something in the polar form. Is that understandable? Yes or no?
Yes.
Yes. Okay. So let me just try to do some exercises together. Let me see. So let me teach the next part. This is easy, I think. It's not hard. So you learn how. But so for example, let me ask you something. Can you write the polar form of this number for me? Just you can do it in your head. Okay. So I give you z equals to 1. What is the polar form of this? This is the simplest possible number. We want to make it harder. So what is the polar form of just z equal to 1? Two things you need to think about: absolute value and the argument. What's the absolute value?
1.
It's clear it's 1, yes? So I would write this is equal to absolute value of 1 is 1. And then what's the argument? Can you imagine?
0.
It is 0, yes? Because it lies on the real axis. So you just write it like this. So, yes. So instead of writing 1, you write like this. If I ask you what is cosine of 0, what is cosine of 0?
1.
Is 1. What is sine of 0? Is 0. So if you calculate this, you will definitely get 1. But the point is not to simplify this thing. This is the first time we are making things a little bit hard. So can you tell me what is the polar form for this z equals to I? Z equals to I. What is the polar form of z equals to I?
1.
The distance is 1, so you write 1, the absolute value. Everybody happy with the absolute value is equal to 1? The distance from the tip of the vector to the origin. So it is 1. And what is the argument here? Pi over 2, yes? It's on the, so here is your I. So this angle is pi over 2. So you would write it as cosine pi over 2 plus I sine pi over 2. Again, let me just repeat. If I ask you what this number is 0. What this number is 1. If you multiply everything, you really get the correct answer. It is I. But the point is to keep it in that way. Is that understandable? So this is the meaning of putting it in polar form. Okay, now we want to talk something interesting. We want to see that if I have two complex numbers in the polar form, how can I multiply them and how can I divide them? Of course, it is not something, this is not a new lesson. You can just multiply it as usual and you can divide them as usual, even though the numbers involved look more complicated. But in principle, this is doable. But let us do it once for all. You will see there would be a nice relation coming out. And then that formula is also in the formula sheet. You can always use that. But it is extremely important to understand what is going on. Yes? Okay, let us try to discover the formula together. I give you two complex numbers in the polar form. Before doing that, let me ask you one question. Be careful. What was this number here? Let me just talk a little bit here. So z equals to r cosine theta plus phi sine theta. Okay, this is called the polar form of a complex number. What type of this number you expect to see here?
A real number.
A real number, more than that.
A positive.
A positive real number, yes, because this represents absolute value. For example, can I say this is a polar form? Is this the polar form of a complex number? No. Why? Because the number sitting behind a pair of brackets is a complex number. So even though it has the right structure, but you cannot call it a polar form because this number is complex. Can, for example, this be a, I don't know, for example, -2, let me call it z1, let me call z2 here. -2 times cosine of pi plus I sine pi. Do you think this is a polar form?
No.
It's not, because that -2 is negative. Now my question, write it in polar form. So you realize that this complex number is not in the polar form. Yes, be careful. These two have the same structure, but when this is polar form, this angle should be between 0 and 2 pi, and this number should be a positive real number. If this is not the case, because the structure is the same, you cannot call it the polar form. But can you now write it in the polar form? For example, let us concentrate on z1. How can I write it in the polar form? Yes?
We multiply the polar form of just I.
Yes. Okay. So you are taking. So you say that I multiply the polar form. No, before doing that, because I haven't talked about how multiply two numbers in the polar form. But before that, what is your suggestion here?
Find the polar form for I.
Yes. And then what happens? There is no guarantee yet because we don't know that theorem. How do we know that if I have two numbers in polar form and if I multiply them, it remains in the polar form? But you are right. At the end, we will see this is the case. But you don't need to do that. Let me just multiply I inside. Okay, so what happens? I cosine pi over 2. This is a little bit tricky. You need to know trigonometry a little bit. Of course, you already know, but you have forgotten probably. That's the problem. So if you multiply it, it becomes minus sine pi over 2. Okay, now you want to make it something like this. Can you do it or not? First of all, you see that cosine of pi over 2, so I should appear with sine, but now I appears with cosine. Can you get rid of this problem somehow using trigonometry? Yes?
Cosine of pi over 2 is 0. So
Yes, you are right. But I want to make it sine. What can I do? So you are saying that I write 0 and then -1, so it becomes -1, and then I put it back in the polar form. Yeah, that's correct. Let us just do that. So how do you write it then?
becomes
What is the absolute value now?
1.
1. So let us write it for the time being. And what is the angle?
0.
No, it's -1.
Ah,
it's pi. Yes, because it's on the negative part. So it becomes cosine of pi plus I sine of pi. Yes? So now you see that I started from here, I ended up here. Can I call this one the polar form? Yes, because this is a real positive number and this angle also satisfies the criteria. Yes? Is that clear? So sometimes you need to do these kind of things to be able to put it in the polar form. Okay, now let me talk about this very important reason that we actually are interested in the polar form. Let me consider two complex numbers. Let me, for example, give you a complex number with argument, let me call it Z1, with absolute value R1, and argument theta 1, plus I sine theta 1. And then I have Z2 equals to R2 cosine theta 2 plus I sine theta 2. If I ask you add them, how do you add them? Just say something, it's clear. Well, how should I add them? By the way, let me ask you something. What is the real part of Z1? Can you tell me? What is the imaginary part of Z1? Yes, that's so you have to multiply R1 first, and then the real part R1 cosine theta 1 is the real part of Z1, and imaginary part is R1 sine theta 1. Everyone agrees, so it's easy. Now, if I ask you to add these two, what do you need to do? Do you remember how we should add two complex numbers in general? Yes?
We add the real parts.
We add the real parts, it becomes the real part of the answer, and then we add the imaginary part. So adding them or subtracting them is just normal. Multiplying them is also something normal. But it gives rise to a very nice formula. This is why we want to do it separately. It doesn't mean that I am teaching something new to you. I have given you two complex numbers in a fancy way. We call it polar form. And I am asking you to do the same arithmetic. You can add them, subtract them, multiply them, divide them. Yes? For addition and subtraction, there is nothing new going on. But for multiplication and division, a nice pattern will emerge. So this is why we want to discover that pattern. Is the idea clear? So let us discover it together. Okay? So are you in the mood to discover something or not? Or sleeping? Yes. Especially you know that there is no exam, so let us sleep. Yeah. Yeah. Yes. Are you thinking in that way? Yeah. No. Good. No. Okay. So let us do Z1 times Z2. So tell me, what should I do? I want to multiply these two. Do you agree that I can multiply R1 by R2 and this pair of brackets by this pair of brackets? Is that understandable? Yes. So I would write R1, R2. And I multiply this pair of brackets here. So cosine theta plus I sine theta multiplied by cosine theta 2 plus I sine theta 2. Okay. Yes? But then you need to do a little bit of algebra that I know you enjoy a lot. So how should I do algebra? I have to multiply these two pair of brackets as usual. So cosine theta, let us do some part of it in our head. So cosine theta 1 will be multiplied by that, yes? So I would write it in cosine theta 1, cosine theta 2. But can you tell me what would be another real part coming out? In principle, I should multiply this by that, but let me look a little bit ahead. Do you agree that at some point I have to multiply this by that? Then I times I becomes I squared, which is minus 1. So let me write it here. Minus 1, sine theta 1, sine theta 2. Do you agree? I multiply this by that, I multiply this by that, and I have written these two here. But then this I multiplied here, it contains an I, and then I multiply this by that, it contains an I as well, and I factor an I out. Yes? So what happens? It becomes sine theta 1 times cosine theta 2 plus sine theta 2 cosine theta 1. Yes? And then I have a pair of brackets closed at the end. So tell me, is that understandable for everyone? I'm just doing normal multiplication, yes? And I have used I squared is equal to -1. Okay, now can you tell me, I don't know, if at least this should look familiar for you. If you don't know the detail, but at least you need to know this guy somewhere, yes? Is this reasonably familiar for you or not? Like that, can you don't need to know the details, but what is the name of these formulas in trigonometry? These are addition and subtraction formulas, if you remember we studied in chapter 2. So this formula, okay, so now that you know the formula, you can go to the formula sheet. And then if you trust me on that, this becomes cosine theta 1 plus theta 2. Even if this is negative for cosine, it becomes cosine theta 1 plus theta 2. And the same thing happens here. It becomes sine theta 1 plus theta 2. So this is the nice pattern that we were looking for. So what's happening, by the way, if I multiply two complex numbers, in the polar form, the multiplication is so simple, isn't it? I just multiply the absolute values. I don't need to bother to multiply them in a usual way. I did it once, and I found the pattern. What is the pattern? The argument of this is added to the argument of the other one. Yes? So it becomes cosine theta 1 plus theta 2 plus I times sine theta 1 plus theta 2. Yes? So this is a nice formula. You are so excited now. Yes? So that's a very nice pattern. Now, I don't know. Do you see why we are putting it in polar form now? Do you remember I started with saying that raising to power becomes easier? Yes? Exactly. So that's the reason. You see, I am multiplying two different complex numbers, but we learned the pattern. The complex, these absolute values are just simply multiplied. I don't have any problems with that. The problematic part is multiplying these two pair of brackets. But because of the very special form of this, I don't know, you see, it was not a magic or something. We did calculations and simplified. We realized that the arguments are added. So now imagine that you have one complex number and you want to multiply it by itself. What will happen? This R1 and R2 are the same numbers, so they will be multiplied, no worries. But theta 1 and theta 2 are the same. It becomes theta. If I add theta by theta, it becomes 2 theta. So it is very interesting. If I want to raise this to the power of 2, I simply raise this one to power 2. Instead of bothering to raise this to power 2, I just multiply this angle by 2. Multiplying by 2 is much simpler than raising to power 2. Yes? And of course, we need to use mathematical induction if we want to prove it in general. Okay, but let us not go very fast. This you understand, yes? I had two complex numbers, I just multiplied them, and I got a formula. Is that understandable? Yes or no?
Yes.
Okay, so now let us do... let me ask your opinion about... the division. I want to do the same thing, but this time I want to divide Z1 by Z2, assuming that, of course, Z2 is non-zero. Otherwise, it doesn't make sense. Okay, but before doing that, by the way, this is a level 3 problem in the book. They have asked you to prove it, okay? Yes?
Isn't there a way to do it without mathematical induction? Can we use like a recursive formula?
So recursive is also another way to say that mathematical induction. Yes. Okay, so if you don't mind, let me calculate 1 over z squared first, because I want to find a formula for this one. What do you think will happen? Let us calculate 1 over z squared together. So in principle, you should be able to do this calculation for me. So I would write 1 over R2 cosine theta 2 plus I sine theta 2. Yes? But can you tell me how can I write it? How can I continue here?
To the power minus 1.
Pardon?
To the power minus 1.
Okay, but then no, because we don't know yet. If you want to use this trick For power -1, it is not clear. But because in this way, I can understand what happens to positive powers. There is no guarantee yet the same rule will work for negative powers. Yes? So it is not clear yet. How should I convince myself what you said is true? Let us see how it will work. But you need to be able to do it quickly. So what should I do here at this point? So I haven't been able to teach you this point, yes? What are you facing? You are facing a division. Do you know what is the rule of division? If you want to divide two complex numbers, what was the rule? If you have forgotten that, okay, I agree with you, you cannot say. But if you have it in mind, you should be able to do it quickly. At least the starting point should be quick. So if I ask you to divide these complex numbers, if you have forgotten, I have to regret why I actually ignored this test. But yes, but how should I calculate this? If you don't answer, I will bring the test back. Just try to answer, yes? How should I do that? Not you, that's someone else. Come on. So what should we do? So the first thing that you learn is arithmetic. So it is at this level. In primary school, if you don't understand what is this, it's probably a little bit awful. And don't think that you don't have excuse. You have the excuse here not to do this. At your level, you should be able to do this. Yes, that's normal arithmetic. I give you two complex numbers and I ask you to divide. What was the idea behind that? Yes, Victor? Yes, multiply by the conjugate. Yes, so this is why. I really want you to change something in your future studies. You will see, if you go to technical universities, I am in Koto, I know, it becomes the most stressful of your time ever. Yes, because the lessons are quite compact and short, and then you don't know the professors, and even if you know the professors, you usually are not daring to talk because you don't have this friendly environment there. You might say that, okay, if I ask this question, I will consider me to be a stupid person. I told you that. The next person to you is thinking the same way, okay? So this is why this will go on forever. Yes, might be I can ask some students to come and talk to you about what is the situation. But try to learn these things and try to pay attention a little bit about the memory. There is no way out of it. If you forget about the conjugate rule, it means that you need to start thinking all the problem from scratch. Can you really do that? It's hard. I'm not saying it's not possible, but probably it's hard, and at least the time is not enough to do it in the exam. Anyway, so now can you help me to do this? If I write it in this way, are you okay with writing it in this way? Yes? Yes or no? Yes. Is that understandable? So what I have written is exactly this expression, because this is just one, and instead of writing it in this form, I have written it in this form. Okay, but now what happens? It becomes 1 over r squared. Okay, can you do it in your head? In the numerator, I do it in my head, okay? But you do it in your head in the denominator. What's the answer in the denominator? No, what's the final answer? What's the final answer? Yes?
Is it 1 minus...
No. What's the final answer? Yes?
Is it just cosine?
No, final answer. Oh, okay. I have a typo here. Might be this is confusing. This is Theta. Okay, I give you more time if that's confusing. Yes?
One.
Yes. It should be a matter of seconds. I really feel deep sorrow. Yes? So, why is that? How many times I have repeated you need to respect conjugate rule. Still, some of you start multiplying. Don't do that, even though multiplication will work. Don't do that. Respect the rules. These rules are not that hard. I think opening up an email, sending an email is more complicated task. Believe me, if you go to the level of neuroscience, probably you see that that task is much harder than remembering this. But anyway, the reason is that this is a conjugate pattern. This gives you the first one to the 2 minus the second one to the 2. But the second one to the 2 includes I squared, which gives you another negative sign, so it becomes positive. Yes? Agree or not? But is this famous for you or not? Hopefully you would say yes. What's this one?
1.
It's 1. Yes? So then let us see what happens. By the way, this is interesting. It becomes cosine theta 2 minus I sine theta 2. Okay? Okay. But now, so what is happening? If I want to calculate the reciprocal of a complex number in the polar form, the first rule is easy. Just to calculate the reciprocal, yes, of this absolute value. But something interesting happens here. This combination with positive sign is just simply replaced with the same combination but with negative sign. Yes? Okay, can I call this the polar form? Can I call this one the polar form? Why not? You said no? Yeah, because of negative sign, exactly. Because in the polar form, I should have the positive sign. How can I fix the problem? So if you remember, there was a formula. Cosine of theta 2 can be written as minus theta 2. Yes? Cosine of minus theta 2 is exactly equal to the cosine of theta 2. Yes? What is the same relation for sine? Can I write it positive I sine minus theta 2? Do you remember cosine of minus alpha is equal to cosine of alpha? But sine of minus alpha is minus sine of alpha. Is that understandable? That is something we had in trigonometry. Now, what is happening? Can I say that this is more or less the polar form? Yes, because I have a positive sign here. So what can you say? You can say that the absolute value changes to 1 over the absolute value, but the argument was theta 2. Now it becomes minus theta 2. Yes? But of course, it should be in a new convention. Because if theta 2 is between 0 and 2 pi, minus theta 2 would be between minus 2 pi and 0. Yes? So if you want, you can bring it back to the normal convention. But at least what I have written here from algebraic point of view is completely correct. Yes? Okay, so what does it mean? We found the second pattern. The first pattern is how to multiply them. The second pattern is how to find the reciprocal of a complex number in the polar form. The idea is simple. Calculate the reciprocal of the absolute value and change the sign of the argument from positive to negative or negative to positive. Yes?
The readout point from changing the first argument, the cosine multiplies.
Yes, because these two should match. If I change this one to, if I just keep it this one theta 2, this one minus theta 2, they don't match. If I want to write it in the, that was a good question, by the way. He is asking why we just wrote this one, because that's the same thing. If I don't do that, here would be theta 2, here would be minus theta 2, but in the polar form, these two angles should be exactly the same. So this is why I have to put it in that form. Thank you for the question. Okay, is that clear now? Okay, so now can you solve this problem for me from scratch? So what can I do here? I want to solve this problem combining the idea of multiplication and reciprocal. How can I do that? Can you tell me? First of all, how should I imagine this? Yes?
Z1 times 1 over Z.
Excellent. Okay, so Z1 times 1 over Z2. What Z1 is this number. 1 over Z2 is this number. I am no longer dividing, I am multiplying. Yes, I know the rule for multiplication. What was the rule for multiplication? Multiply the absolute values. Yes. So what is the absolute value of Z1? It's R1. What is the absolute value of 1 over Z2? It's 1 over R2. If I multiply these two, it becomes this. And can you tell me what should I do? I need to add, when multiplication, I need to add the arguments. The argument of Z1 is theta 1 plus the argument of Z2 is minus theta 2. Yes, understandable? Now, what I can write it more compactly here for you. Okay, so Z1 divided by Z2. Instead of writing it so strange, I can write it as R1 divided by R2. And instead of writing theta 1 plus negative theta 2, I can simply write theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Yes? Is that understandable? So we had two nice patterns. If I want to multiply two complex numbers in the polar form, in principle, you don't need an extra formula. You can do it from scratch all over. Just multiply them. And you don't need to do anything new for division. You can just follow the rules. But these are so nice formulas, and the consequences we will explore about these formulas are rich. So we do it once and use it all the time. Yes? Is that clear? So if I want to end up this derivation here, I would say that if I have two complex numbers in the polar form, to multiply them, just multiply the absolute values, add the arguments. If you want to divide the absolute values and subtract the arguments. Is that understandable? Yes or no?
Yes.
Okay. So, yeah, I think it would be good if I stop here. So I will continue the lesson next time. Yes, so I will continue the lesson until the very last day that we are in school, because this is a very important topic. At least if you want to learn it in the future, there are some videos recorded. If you don't want to listen right now, you can listen later, okay? Thank you very much. Thank you very much, people at home. Do you have any questions? I will be in Zoom.